class. You're welcome to Easy Pass Tutorial. Our topic for today is quantitative analysis. Chemistry practical question is divided into two main parts. One is quantitative analysis. The second is qualitative analysis. Under quantitative analysis, we have the volumetric analysis. Then we have the gravimetric analysis. Volumetric analysis is a process, or it can be defined as a process of measuring volume of a solution. Measuring volume of a solution of a reactant in a chemical reaction. A process of measuring volume of a solution of a reactant in a chemical reaction, so as to determine the amount of the reactant. What about gravimetric analysis? Gravimetric analysis is a process of weighing and determining the mass of a reactant and product. A process of weighing and determining the mass of a reactant and product. In volumetric analysis, we have three aspects of volumetric analysis. One, we have acid-base titration, which is common to white particle, so which is common to general particle in chemistry. We have acid-base titration, that is very common. We have redox titration. We have precipitation analysis. Under acid-base titration is a titration that involves a reaction between acid and base. Under acid-base titration is a reaction that involves a reaction between acid and base. In redox titration is a reaction in which part of the reactant, is reducing while the other part is oxidizing. It involves addition of hydrogen and removal of oxygen. On the other hand, it also involves addition of oxygen and removal of hydrogen. Addition of hydrogen and removal of oxygen is called reduction reaction, while addition of oxygen and removal of hydrogen is called oxidation reaction. Under acid-base titration, we have what's called a transition reaction. It's a reaction between acid and base to give salt and water. There are formula that is involved when solving volumetric analysis. When carry out volumetric practical, we have what's called burette, we have pipette, the burette for acid, we have pipette for base, depending on the volume of acid you are being asked to measure, and the volume for base is constant. It's always constant at 25 centimeter cube or 20 centimeter cube. Because the standard volumetric flask is 1000. The standard volumetric flask is 1000. When solving question, the standard volumetric flask, which is 1000, is always used or is mostly used when solving volumetric analysis. Example of those formula that are used in volumetric analysis, when you're asked, we have molar concentration, we have mass concentration, we have molar mass, sometimes we have number of mole, so for molar concentration, it can be that of acid, it can be base, acid to base. Mass concentration, it can be that of what? Acid to base. Molar mass, it can be compound of acid to base. Number of mole, it can be number of mole of acid to base. If you are asked to calculate molar concentration of acid or calculate the concentration of acid in mole dmq, if you have to calculate concentration of acid in mole dmq, sometimes the acid might be given to you in gram. They ask to calculate the acid in mole dmq. You have to use this formula, which is molar concentration. Molar concentration is equal to mass concentration all over molar mass. If you have to ask to calculate mass concentration, you have to make mass the solution of the formula. By this, you cross multiply. When you cross multiply, it not be mass concentration. That's to say, calculate for mass concentration of any acid or base. It not be for mass concentration is equals to molar mass molar concentration, which is this, times molar concentration times molar mass. Then if you have to calculate for molar mass, you divide molar concentration all over what? Mass, so you get your molar mass. We have what's called volume of acid. Volume of acid is all represented as what? dA. This one means volume of acid. Volume of acid. We have volume of base, which is represented as what? dB, which stands for volume of base. We have number of acid. Number of acid stands for what? Na. Na stands for what? Number of acid. While Nb stands for number of base. For you to have the volume of acid, sometimes you have to make a table. You have to make a table by using an indicator to determine the color change of the reaction. Indicator that are used under volumetric analysis: 1 is meter orange, 2 we have phenolphthalein. All these 2 indicators are used under volumetric analysis to determine acid-base titration. What do we mean by the word indicator? Indicators are weak organic acid and base which determine the color change of a reaction during acid-base titration. A weak organic acid and base that determine the color change of a reaction during acid-base titration is called an indicator. 2 major indicators are used, which is meter orange. If you are titrating strong acid against strong base, you can use any indicator. You can use either meter orange or phenolphthalein. In a situation whereby you are titrating strong acid against weak base, you use meter orange. If you are titrating strong acid against weak base, you use meter orange. When titrating weak acid against strong base, you use phenolphthalein. When titrating weak acid against strong base, you use phenolphthalein. Meter orange in base is yellow in color, while in acid is pink in color. Phenolphthalein in acid is colorless, while in base is pink in nature. With this explanation, we have to carry out some example related to why question. We want us to tackle some question under volumetric analysis. Stay tuned. I'll be right back. Thank you.